Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. Today's lecture is about another aspect of the data, that is the spread or the dispersion of the data points. So for this purpose, first of all, we are discussing standard deviation or variance. So let's start the lecture. Variance and standard deviation. Both variance and standard deviation are the measures of the spread of the dataset. But variance is a measure that describes the dispersion of the data points in square units, while standard deviation describes the dispersion of the observations in the same units. So this is the only difference between these two. Otherwise, they are describing the same phenomenon of our dataset. So let's define each one of them. We define variance as the measure of the spread of the observations about their arithmetic mean is called the variance. It measures the spread of the observations around the arithmetic mean, but it gives the result in square units. Whatever units the observations are having, it shows the results in its square form. So this is the definition of the variance. But do remember, the definition of the variance is something different from its computational procedure. So most of the times, the students are giving the computational procedure as the definition. So from my point of view, this is incorrect because the definition should be different from the computational procedure. The definition should be purely theoretical. It shouldn't be any description of the computational procedure. Okay, so this is the definition of the variance. Now, how do we compute variance from a data set? So let's describe that. Computation of variance. Variance can be computed as the sum of the square deviations of the observations from their arithmetic mean divided by the total number of observations. What is square deviation? Now, first of all, let's know about deviation. What deviation is? The subtraction of two numbers is called deviation, or the distance of two numbers is called deviation. When we subtract the arithmetic mean of a data set from each of its observations, so we get deviations. And when we square those deviations and then sum them all and divide that total by n, so we get the variance. So this is the simple mechanism. That is, subtracting the arithmetic mean from each of the observations of a data set and then squaring the resulted values, or squaring the resulted deviations and then adding them all and dividing that total by the total number of observations. So then this will give us variance. Next, we discuss the formula of the variance. Now we are discussing formula of variance. So there are two types of variance. One is population variance while the other is sample variance. So first of all, let's define population variance. The population variance is denoted by sigma squared and can be defined as summation x minus mu squared divided by capital N. Capital N is the population size or the number of units in the population. So this is the formula of population variance. Now its sample counterpart will become sample variance. So sample variance is denoted by h squared and can be defined as summation x minus x bar squared divided by small n. Small n is the sample size. The number of units in a sample is called n, or sample size. So this is the formula for the population variance and this is the formula for the sample variance. If a sample data is given, so then we will use this formula, and if the population data is given, so then we will use the above formula. These are the basic formulas for the variance in population case as well as in the sample case. What does this formula show? It shows that the mean of a data set must be subtracted from each of the data points and the results so obtained will be squared and then all the squared results will be summed up to get a total, and then that total will be divided by the number of observations to get the variance. Now if we look at the formula, so first of all we need the mean of the data set, that is the population mean, as this is the population case. Similarly, in the second formula, first of all we need the sample arithmetic mean. After computing the sample arithmetic mean, then we will subtract the sample arithmetic mean from each value of the variable, and the results so obtained will be squared, and then all the squared results will be summed up to get a total. After getting a total, that total will be divided by the sample size to get the sample variance. So if we look at to both of the formulas, so first of all we need the corresponding arithmetic means. After getting the arithmetic means, then we are able to compute the variance. But there are alternative forms of each of these formulas which don't require the computation of the mean first. Without the computation of the means, we are able to compute the variance. So those formula can be obtained by solving these quadratic forms. So if we solve this quadratic form, and after some simplification, we will get this formula like this. So now both of them are exactly the same formula. This is the raw form of the formula, while this is the simplified form. Both of them will yield the same results. And similarly, if we solve this quadratic form and simplify this formula, so we will get this formula is, so now this is an alternative form of this formula. So in practice, instead of these formulas are used. But these are the basic formulas of the variance, and these are the derivations from these basic formulas. Whenever we are talking about the basic formulas of the variances, so do remember we are talking about these two formulas. Okay, now we have discussed variance. What is standard deviation? Both are very related terms, but as we have discussed over here, that variance is the measure of the spread of the observations about their arithmetic mean, but variance gives the results in the squared units. Now, what is standard deviation? Standard deviation is the same measure of the spread of the observations about the arithmetic mean, but standard deviation gives the results in the linear units. So this is the only difference between the variance and the standard deviation. Variance is the square of the standard deviation, and whenever we are taking the positive square root of the variance, so it becomes the standard deviation. So both of them have these relations, and one can be obtained from the other. If we have variance, so we can obtain the standard deviation, and if we have standard deviation, so we can obtain the variance. Okay, so if we modify this variance for the standard deviation, so this will become, okay, so now this becomes the standard deviation. Standard deviation, the measure of the spread of the observations about their arithmetic mean, is called the standard deviation. So we have modified the definition of the variance for the standard deviation. Now, how is the computation of the standard deviation? Standard deviation can be computed as the positive square root of the sum of the squared deviations of the observations from their arithmetic mean divided by the total number of observations. So over here, now we have used the positive square root. So if we take the positive square root of a variance, so it automatically becomes the standard deviation. Now, formula of the standard deviation. Population standard deviation. So if we take the positive square root of the variance, so it will become standard deviation. So when we take the positive square root of sigma square, so root and square will be cancelled out, and it will remain only sigma. And at the right side, the square root will remain. And this is the simplified version of this formula. Similarly, if we take the positive square root of the sample variance s squared, so the square root and the square will be cancelled out, it will remain simply s, and at the right side the square root will remain. And this is the simplified form of the sample standard deviation. So these were all about the variance and standard deviation of our dataset. I hope this will help you in the conceptual understanding of variance and standard deviation and the corresponding differences between them. Thank you for watching the video.